Am I audible to you? Okay, so let's start. So question is, how is SO2 an air pollutant? SO2 जो है अपने आप में एक एयर पॉल्यूटेंट है. कैसे? एक तो when SO2 is mixed with water, that form acid rain. What it forms? Acid rain, and that can dissolve marble or many things. It can cause eye irritation. In high concentration, it can cause eye irritation. Even in low concentration, it can slows down the formation of chlorophyll. That's why leaves that fall down if SO2 is present in air. So these are the 3 points where we can prove that SO2 is an air pollutant. So I will write it. First is, I can start from here. SO2 acts as an air pollutant because of the following reasons. So first reason, is it visible? Yes. First is SO2 is strongly irritating to the respiratory tract. Okay, and SO2 at a concentration of 5 ppm causes throat and eye irritation. This part we have covered in class 11 as well, है ना? Resulting in cough, tears and redness in eyes, or it causes breathlessness, and affects वॉइस बॉक्स. वॉइस बॉक्स भी खराब हो सकता है. क्या बोलते हैं उसको? नेक्स्ट. So SO2 जो है that acts as an air pollutant because of the following reasons. First is SO2 is strongly irritating to the respiratory tract, and SO2 at a concentration of 5 ppm that causes throat and eye irritation. Even it causes breathlessness and affects voice box. Okay, or say it causes throat and eye irritation. So when you travel by bike or scooter, then there is redness in your eyes. That is because of SO2 present in air, or it can cause cough, okay, because it causes throat irritation as well, okay. Second is that I told you that SO2 can be used to slow down the formation of chlorophyll, and if chlorophyll formation is slowed down, then leaves can fall down, okay. So even at low concentration of 0.03 ppm, so see how small concentration it is, 0.03 ppm, it has a very damaging effect on the plants. What it do, if exposed for a long time, that is a very few days or weeks, then it slows down the formation of chlorophyll, resulting in injury to leaves, including loss of green color, because green color of plants means leaves is due to chlorophyll. And that is called chlorosis. This is called chlorosis. वापस, okay, I will write for some time. ठीक है, ओहो, ओके, तो यहाँ पे थे हम, है ना, कि if question is how is SO2 an air pollutant, so you will write कि SO2 acts as an air pollutant because of the following reasons. First one is कि SO2 जो that is strongly irritating to the respiratory tract, and SO2 at a concentration of 5 ppm that causes throat and eye irritation, means it causes cough and redness in eyes, okay, it causes breathlessness and affects even voice box, okay. Even at low concentration of 0.03 ppm only, it has a very damaging effect, okay, on the plants, because it slows down the formation of chlorophyll. And this chlorophyll is responsible for the green color of the plant or green color of the leaves. So in this way, what happened, it leads to the loss of green color, This is called chlorosis. Means those leaves turns yellow due to the presence of SO2 in the atmosphere, or even SO2 dissolves in rain. And you know, SO2 when dissolved in water, it gives H2SO3. H2O when dissolved in water, sorry, SO2 is dissolved in water, it gives H2SO3. And this H2SO3 that can damage building materials, especially marble. So calcium carbonate is dissolved in sulfurous acid. So give calcium sulfite along with water and carbon dioxide. It can corrode metal even. Some metal can be corroded like even iron, steel. It can cause corrosion of metals even. Okay, that's why SO2 is an air pollutant. Okay, so next question. Question number 23. So question is, why are halogens strong oxidizing agents? Why are halogens strong oxidizing agent? First of all, you know, halogens are oxidizing agents because they have tendency to gain electrons. And you know, after gaining one electron, okay, they have complete octet, first thing. And second thing, you know, the reaction is like X2 gas, half X2 gas plus electron to give X negative aqueous. This is the case, okay. So first of all, X2 gas is converted into X gas, and energy involved here is called dissociation enthalpy. What we call it as dissociation enthalpy. And then X gas is converted into X negative gas because electron is gained in the gaseous state. Electron is added to the gaseous atom, isolated gaseous atom. So energy involved is called electron gain enthalpy. And third is when X negative gas comes in contact with water, because you know, oxidizing and reducing action is in the aqueous solution. So that is called hydration enthalpy. Okay. So question is, why are halogens strong oxidizing agents? So everybody knows, okay, because they can gain electron. Okay. Their E0 values are more positive. But why these E0 values are more positive? That is because of these three processes. First is enthalpy of dissociation. So first factor which is in favor is low bond dissociation enthalpy. Low bond dissociation enthalpy. Second reason is high negative, yeah, more negative electron gain enthalpy. More negative electron gain enthalpy. And third reason which is in favor is high hydration enthalpy. Because of high hydration enthalpy, because you know, this is the energy absorbed. So it should be low to make this process feasible. Electron gain enthalpy, it is the energy released, so it should be more negative. Hydration enthalpy, it is the amount of enthalpy released or energy released when 1 mole of ions interact with water by ion dipole attraction. This is amount of energy released when 1 mole of ions interact with water by ion dipole interaction. By ion dipole interaction. Okay. So these are the 3 factors which are in favor of halogens. So they are strong oxidizing agents. And if we compare the same for fluorine and chlorine, so in case of fluorine, you know, fluorine is strongest oxidizing agent. Reason is its dissolution enthalpy is very low, even lower than chlorine. Okay, and very high hydration enthalpy. You know, electron gain enthalpy of fluorine is less than that of chlorine because of very small size, because added electron feel more inter-electronic repulsion. Got it? So you should write these 3 factors: low bond dissolution enthalpy, more negative electron gain enthalpy, and high hydration enthalpy. Okay. Now, next question. Question number 24. Explain why fluorine forms only one oxo acid, that is HOF. So question is, explain why fluorine forms only one oxo acid, HOF. So actually in many books it is written that fluorine has +1 oxidation state in it. Even in Pradeep it is written like that, most of the books. But I think it's wrong. Reason being, in every book it is written that fluorine has only -1 oxidation number in its compounds because of its high electronegativity. So I think the justification for this is that fluorine has only one unpaired electron. Fluorine has only one unpaired electron which can be shared with oxygen because it is HOF, right? So fluorine can form only one bond. It is because first fluorine has only one unpaired electron. It is most electronegative. It is most electronegative and has no vacant d orbital and has no vacant d orbital. That's why fluorine can form only one bond. It cannot form more than 1. But chlorine, that has vacant d orbital, so electron can be excited to next d, and that's why that can form more number of bonds. This is the proper reason according to me. So you should write that fluorine has only one unpaired electron. It is most electronegative and has no vacant d orbital, so it can form only one bond, not more than that. But rest of the halogens, they have vacant d orbital, therefore they can form more than one covalent bond, right? Okay, next question number 25. Explain why in spite of nearly the same electronegativity, oxygen forms hydrogen bonding while chlorine does not. Question is, explain why in spite of nearly the same electronegativity, oxygen forms hydrogen bonding while chlorine does not. So reason is very simple. Tell me what is the reason. Hydrogen bonding is formed when hydrogen is attached to an atom which is small in size and high in electronegativity. So that means chlorine and oxygen both are satisfying second condition, that is both are more electronegative, but oxygen, first we will write the condition. Okay, hydrogen bonding is formed by an element when attached to hydrogen having two condition, having satisfy, yeah, which satisfy two conditions. First condition is element should be small in size. First condition is element should be small in size, and second condition is element should be more electronegative. Okay, so out of these two conditions, second condition is satisfied. Second condition is satisfied by oxygen and chlorine both, because they have nearly same electronegativity, but oxygen being small in size can form hydrogen bonding, but chlorine being large in size cannot form hydrogen bond. But chlorine being large in size cannot form hydrogen bonding, right? So this is the proper reason, I think. Okay, now question number 26. Okay, we can hydrogen bonding intrachlorine V. Then beta that is in special cases. Chlorine is not involved in hydrogen bonding. Okay, in special conditions it can form, but in normal conditions chlorine is not allowed to form hydrogen bond. Okay, like if you have HCl, okay. Now question number 26. Write two uses of ClO2. So first of all, you know, ClO2 is a powerful oxidizing as well as chlorinating agent. ClO2, and you know ClO2 is an odd electron molecule. ClO2 is an odd electron molecule. That's why it is a bleaching agent as well. So these are the two main uses. First, ClO2 is a powerful oxidizing and chlorinating agent, and second is it is a bleaching agent. Okay, so I will write first, ClO2 is a powerful oxidizing agent and chlorinating agent. So large quantities of ClO2 used for or no need, because this question came in 1 mark. Okay, so you should write first it is a powerful oxidizing agent and chlorinating agent, and second you should write it is a bleaching agent. It is an excellent bleaching agent. That's it. Okay, question number 27. This 27th question is very important, so please note it. 7.27. Why are halogens colored? Question is why are why are halogens colored? Very simple question, but it is very important. So, beta, answer to this question is, halogens have one unpaired electron, or if you talk about F2, Cl2, Br2, I2, they form diatomic molecules. Now, energy required to excite their electrons that fall in the visible region. So when electrons are excited and when they fall back, okay, they fall back in the visible regions. That's why they are colored. Got it? In halogens, when electrons are excited and then when they fall back in the visible region. That's why they are colored. Okay? Any substance is colored only when they fall in the visible region. Okay, that's why they look colored to us. Okay, so this is the simple reason. All halogens are colored because their molecules absorb light in the visible region, as a result of which their electron get excited to higher level while the remaining light is transmitted, and the color is actually the color of transmitted light. Means when visible light is passed through them, in their molecules, the electrons get excited in the visible region. Okay, so remaining light is transmitted. So the color is actually of transmitted light. That's why fluorine, chlorine, iodine, bromine, iodine, they have different colors. Iodine, it has violet color because energy required to excite its electron is very less. If you compare fluorine, chlorine, bromine, iodine, least amount of energy is required for iodine, and that's why when electron fall back, when transmitted light is seen, that transmitted light is of higher energy because low energy radiation is absorbed in the excitation. In exciting the electrons, low amount of energy is required, and that's why transmitted light is of higher energy. That's why iodine is violet. See, F2 absorb violet light and therefore it appears pale yellow. It appears pale yellow. Fluorine और iodine जो है that absorbs yellow and green light and therefore it appears deep violet. Okay, greenish yellow color of chlorine, greenish yellow for chlorine और bromine का red. Okay, so if question is why are halogens colored, you can simply write that in visible region their electrons of their molecules are excited in the visible region. Okay, and therefore rest of the energy is transmitted and color of the halogens is actually the color of the transmitted light. Okay, so in fluorine, huge amount of energy is required to excite the electrons. Violet color is required to excite its electron. That's why fluorine transmitted light has pale yellow color. Okay, but in iodine, low energy radiations are required to excite its electron. Therefore, transmitted light is of higher energy. That's why it is deep violet. And similarly, chlorine are greenish yellow and bromine is red. Done? Okay. With your very good. Okay. Now question number 28. Question is, write the reactions of fluorine and chlorine with water. So they give different products. Why? Because fluorine is very strong oxidizing agent, so it can oxidize even water. See, fluorine is a very strong oxidizing agent, so it can oxidize even water into O2. It can oxidize water into O2. Therefore, fluorine change into F negative, H plus aqueous, and O2 gas. So that means fluorine being very strong oxidizing agent, it can oxidize water to give O2 gas, right? Even it can give O3 gas. Yes, O2 as well as O2. O2 and O3 gas. Just balance it, 2 H2O. So 4H plus 4F negative. And here, O3. So 3H2O. So 6H plus. So 6F negative. But chlorine, it form oxo acid. Chlorine simply form oxo acid. It form HCl and HOCl. And even it can lead to the formation of 2HCl and nascent oxygen. So chlorine water, this is called chlorine water, that can act as an oxidizing agent, and it is yellow in color due to the formation of HOCl. Chlorine water is yellow in color due to the formation of HOCl. What is name of HOCl? It is called hypochlorous acid. So while writing the difference, just write fluorine being stronger oxidizing agent, it can oxidize water into O2 and O3. And chlorine, when dissolved in water, it gives HCl and HOCl. That's why chlorine water is yellow in color due to the formation of hypochlorous acid. Right? So that's all for the day. Thank you so much for watching this video. Do like, subscribe and share my channel, and please share with your friends so that it is publicized, okay, or more people can watch it and get benefit from my channel. So that's all for the day. See you tomorrow at the same time, that is 8 p.m. okay, to 8:40 or 8:40, around about 8:50. Actual time is 8 to 8:45. Okay.